Hello! Today we're going to be concentrating on graphing square roots and cube roots. The first part, we're just going to do a sketch. Key is a sketch. If I don't give you a 10 by 10 grid, you don't have to plot exact points. We're just getting a rough idea of what it's going to look like. So we have y equals x squared. We know what x squared is. That is a parabola. And then we're going to graph its inverse. You remember this, we've learned this. Graphing the inverse is reflecting over that line y equals x, switching the x and y coordinates. So when I have the inverse of this parabola, it's going to turn to the side. Number 2, we have y equals x cubed. X cubed is that snake-looking graph here. This was our f of x. This was our inverse. Here is our original. Again, we reflect over that line, y equals x. And we get that reflection. Our graph, that wasn't very good. That wasn't good either, but we're gonna run with it. There is our inverse. So when we have y equals x squared, the inverse graph goes to the side. This right here is going to be representing that square root graph, because the square root, x squared, those two are related, but it's only going to be the top half because of the x squared. Normally you would have the plus or minus, but we don't have the plus or minus with the square root. So all of our square root graphs are going to have this kind of shape. In blue, we have that S-shaped graph going up and down. That's the original function. The inverse of x cubed is going to be the cube root. So all cube root graphs are going to have that kind of shape to kind of get you going with what you should be looking for. Those are the shapes that we're going to be concentrating on. This is going to be the square root graph, and this is going to be the cube root graph. And the good news is you're always going to have your calculator there to help you. So some graphing practice, and we know we just talked about where we're going to start off. We have the square root, we have the cube root, and then we have all of the transformations. So this is going to be a really good review of our transformations. It wants us to start off by identifying the parent function. Remember, the parent function is the function without any transformations. So if I strip away the -4 and the +2, the parent function is the square root of x. And don't forget that the square root of x is the same thing as x to the 1/2 power. You're going to be seeing it written both ways. So the transformations, we always start on the inside. Anything inside is the horizontal, so the +2 is telling me that I'm going left 2. The -4 tells me that I'm going down 4. So that square root graph that we saw above, right here in yellow, I'm taking that graph and I'm going left 2, down 4. So my graph's going to end up over here somewhere. And what are those points? Don't worry, we can go to our calculators for it. So we go to our y equals, clear out what we had. So I hit second x squared, that's how I get my square root, x plus 2. And then notice how I'm still underneath the square root. You want to make sure that you arrow out of the square root to do the -4. Because when we look at our equation, the -4 is not underneath that square root. So just make sure that you're entering the equation to your calculator correctly. We go to second graph. I have some errors there. We're going to get to that, but I'm going to look at all of those points that are going to fit on our grid. And we're going to choose some good points here. So -2, -4, that's a good one. -1, 3, that's a good one. 2, -2, That's a good one. As I arrow down, I see that it's just getting smaller and smaller and smaller. So let's go ahead and plot these points that we found. We saw -2, -4. We saw -1, -3. And we saw 2, -2. And that supports what we found. Remember, we were taking the original, which was here. That's the square root of x, the parent function. And we moved it left 2 and down 4. So every point here is going left 2 and down 4, showing those transformations. That is our square root graph. We want our domain and our range. So if I'm looking at here, this is my stopping point. It's not existing anywhere, and then my arrow is going this way. So domain is the x's. I think about my movement left and right. Well, this is as far left as my graph is going, so my domain is all x's that are greater than or equal to that -2. Your range is in terms of y, so that's your movement going up and down. I see that this is the lowest point on my graph. This arrow, although it looks like it's just going to the right, it's going to the right and it's going up. So my range is going to be everything greater than or equal to -4, because -4 is the lowest point and it's everything above. For my domain, -2 is the farthest left, and my graph existed everywhere to the right. All right, let's move on to our next one. We have y equals a -2, x minus 3 to the 1/3 plus 4. What is the parent function? Remember, we strip everything away. We take away that -3, the -2, the plus 4. Our parent function is y equals x to the 1/3 power. Again, this is the same thing as the cube root of x. Radicals are fractional exponents. We got a lot of transformations here. On the inside, that -3 tells me that we're going right 3. The -2 multiplier is telling us two things. One, that we are reflecting over the x-axis. And 2, because it's multiplying by 2, it is a vertical stretch by 2. And then last, the plus 4 on the outside tells me that I'm going up 4. So when we think about that parent function that we looked at up here, I'm taking that parent function and I'm going right 3. And the center of this is this point right here, that point where we're switching directions. I'm taking that point, I'm going right 1, 2, 3. I'm going up 4 and I'm reflecting it, which means everything is being reflected over the x-axis, and I'm stretching it vertically. Whole lot going on there. But that's why we have our calculators to help us out. So we're back in our y equals, clearing out what we just did. -2 parentheses, x minus 3, close parentheses, raising that to the 1/3 power. So I just did 1, the division sign, 3. I'm still in the exponent, so I want to make sure that I arrow to the right to get out of there, plus 4. Again, we can see our graph here, everything that we expected. We were here at 0, 0. We went right 3. We went up 4. There's that reflection. You can see how it's going this way. And with our parent function, it was going here. So let's go ahead and look at some points. So we go back to second graph, and we want to pick all the points that are going to be good points on the graph. So that's fitting between that 10 by 10. So we see -5, 8, 2, 6, 3, 4, 4, 2. And 11, 0. So that's going to be off our graph a little bit. Let's go ahead and plot these. So negative 5, 8 was one of those points. 2, 6, 3, 4, 4, 2, and then 11, 0. So right here, this is one of the important points. See how that's where we're changing directions? That little loop in our graph here. So that's always going to be symmetrical on each side. So just keep that in mind. Domain. Domain are your x values. If I'm looking at my graph going left and right, my arrow is forever going left, my arrow is forever going right. That's all real numbers. My range, that's going up and down. Remember, this is forever going left, but it's also going up. This is not just going to the right, it's also going down. This is always all real numbers. So your cube root graph will always be all real, unlike your square root graph, which will have restrictions on both the domain and the range. All right, last, writing these equations. So we just reviewed our transformations. We're going to remember how to write our equations here. Given the following transformations, write a single equation using the parent function. So we're going to go left 9. Well, if I'm going left 9, remember that happens on the inside, and it's the opposite. So I have x plus 9 on the inside of my radical, expanded vertically by a factor of 3. That means I've got 3 times the cube root of x plus 9. And then shifted up 1, our vertical movement is going to happen outside of that radical. Notice how my plus 1 is clearly not underneath the radical. If you kind of have messy handwriting, you may want to put parentheses reminding yourself, okay, only this is underneath the cube root. All right, there are all of our transformations. There is our final equation, and we are all finished.